graph. So we have the following diagram shows the graph for the function y is equal to 2x plus x minus 2. So we have the quadratic graph here. You'll pray if they bring graph and stuff tomorrow, which it would bring some type of graph, you'll get the actual graph. Like it's like, you don't have to draw the graph. I mean, nothing is wrong if you have to draw the graph, but when you have the graph already, you just have to answer a few questions from it. So let's see what I have here. So from the graph, see the roots of the equation. The root of the equation has to do with the x values. Okay, the x values. You're probably saying, what? Do you remember when we did quadratics? Um, a quadratic, when you either if you use a formula or you use the factorization, yes, I think I did some factorization. Um, you tend to get two x values. That is the root of the equation. So you don't have to factorize this, because you have a graph. If you didn't have a graph, you could go ahead and factorize it and find the two x values or use the quadratic formula, that is normally on the past paper too, which is minus x, not minus x, minus b plus or minus the square root of b squared. Take away 4ac all divided by 2a. But when you have a graph, do not waste your time. Learn to read the graph. So this quadratic intersects the x-axis at -2 and 1. So the two x values are -2 and 1. The roots, that's why they said roots, right? Plural. The roots are -2 and +1. Okay, I hope that is clear. You don't want to go wasting your time using quadratic formulas of a thing when you have a grid and when you have a graph. The next part says coordinates of the y-intercept of the function. Y-intercept means the point where the graph intersects, cuts, meets with the y-axis. Let me see if anybody can tell me what is the y-intercept of this graph? What is the y-intercept? But they want the coordinates, but you can at
4,
least give me
4,
word. No. Which number does that quadratic intersects or meets with the y-axis? Uh-huh. So, thank you for
is
trying,
it?
Ophelia. Uh-huh.
No. I'm not gonna ask if it's 3.5 and the -3.5. Yeah, no,
No.
that'll be why. Mm.
Ophelia, the y-axis is here, right? Y-axis is here. The graph is here. Where do they meet?
That's -2.
Yes. So that's the y-intercepts. But they want the coordinates. So it's actually 0, -2. Now, if you're wondering where 0 coming from, let me go back up. Any point located on the y-axis, the x-coordinate is 0. Every time. All the time. What did I do just now? Sorry. Let me clear this from here. So, because this point is on the graph itself, it's on the y-axis. Of course, we know it's -2 for y, but how do we know x? The x-axis is here. If we go up to the x-axis, that's where x is 0. So the coordinates are 0 for x, -2. Another thing I must tell you, all right, this same question above here could come as, instead of them saying roots, they could tell you values. I've seen that in past people. If they say values, is the two x's they're looking for. Or they could also ask you for x-intercept. It just means the two numbers where the quadratic intersects or meets with the x-axis. So there are different ways they tend to ask this one. With y-intercept, they would normally say y. But with x, they tend to say all kind of thing. All right, they want the minimum value of the function. Now, because this quadratic is drawn in this way, it has a minimum value. But just know, if it's drawn the other way, they would say maximum. So, for the minimum value is the lowest point, which will be somewhere around here. The lowest point on this. They said they want the value. They want to ask that question, yeah? They really want the x coordinate, which is also another way they ask this. Oh boy, just now, yeah, they want the x coordinate, right? X coordinate, just a hold on. So if we go up here, is that really giving us the x coordinate? No, this is not the x coordinate. My bad. Let me correct myself, right? It's not the x coordinate, the one here. Just double checking. The one, the minimum value. So that has to be on the y. The minimum or the lowest value is based on the y-axis, not the x. My bad. So I need to change that. I need to change that. Sorry. And put y. This is not the x. If they ask for the axis of symmetry, is the x. But when they say minimum value, the lowest value, you read that from the y. So based on the y-axis, this axis over here, the minimum value is slightly below -2. It is not halfway between -2 and -4. So we could, okay, let me zoom this up a bit. Try, let me zoom it up so you can see it a little better. Okay, sorry. Oh, y'all, I am back again. I don't know what's going on tonight. That wasn't happening with my previous class. So I was like, interesting. I'm getting these, but never mind. I'm here again. Hopefully it doesn't disconnect again. Okay. Um, let's see here. Where's the point again? I had the point over here, right? The minimum, the lowest point. We read that off on the Y. So since we have -2 here, this is like -2.0, right? In this all over. That's -2.0. This line here would represent like -2.1. This other one would represent -2 point. Okay. No, no, no. It can represent 2.1. I have returned once again. I hope this stop. Like, oh my gosh, it's disrupting me, man. Okay, where's the other side? Anyhow, I'll figure that out just now if I need the calculator again. But based on what I was telling you just now, what was I saying? I was measuring it wrong because there are only one, two, three, four, five lines down to -4. So that means each line will represent point 0.2. So here would actually be -2.2. Here be -2.4. Here be -2.6. Here be -2 point, but can't be 2 points. Mm. Because it's not it's not 3.0, so it can't be, wrong scale again. Let's see what going on here. Yeah, wrong scale. So we have to figure out now where is -3. -3 will be halfway, right? So that's what I should have been looking at before. So that means that this line is -3 point or 3.03. Hmm. Yeah, that makes the scale much difficult, but it's doable. So that means, hmm, halfway between -3.0, somewhere around here. Oh gosh, let me get a straight line. That not working out. Halfway between -3.0 and -2 would be like -2.5. So this line is really like -2.5. So that means slightly above it will be around probably -2.4. So this how we have to estimate this. Because this scale is not based on all the how this thing here. We work with -2.4. Okay, we work with that. So anything close enough to that will work. So it's really an estimate as close as possible. So we are going with where was that again? So y, which is the minimum value, it's -2.4. It says the equation of the axis of symmetry. Okay, we don't need to use a formula, but the formula for the equation of symmetry is normally minus b divided by 2a. But when you have the graph, the axis of symmetry is the x value you're looking for. So when it's the minimum value, that's the y. When you see axis of symmetry, that's the x. So it's the same location, but we're reading it all based on the x-axis. Okay, that line don't look that straight, but oh, if it was straight, so let me use a straight line just to get the most precise value. It's around halfway between 0 and -1, so it's around like -0.5 or something. It's about -0.5. Yeah. So if you all get a graph like this, you don't have to use formula and stuff, you just have to read the graph. So the axis of symmetry, the equation of the axis of symmetry means you have to write it with the x. Yeah, you have to write with x is equal to -0.5 or -0.5. If you have questions, let me know. Yeah. Okay, is that it for this? Oh, I wanted to tell you something else. They have something else below. Yeah, before I do that. If instead the graph comes the other way, or if you had to draw it to something, and it's this way, may ask you for the maximum because it's the higher part. So you're looking for like the highest point. You look at the find the middle of the graph and the highest point based on the y-axis you read. So if he has 12 here, would have been like 14. So if this was an actual graph in an exam, it'd be like 40 point something for maximum. And then the same axis of symmetry, just draw a straight line down to the not straight, but I think you understand what I'm trying to say. You draw a straight line to, or you use your ruler to the x-axis and read off where it falls. If it falls on an exact number, good. If it doesn't fall on an exact number, try to figure out the scale between the numbers and get the most precise value. Okay, so what I want here now, it says on the same pair of axes on page 24, draw and label the line Y. Okay, they want us to draw something. A straight line graph. I see. So y equals to 2x plus 4 is a straight line graph. They want us to draw this. How do we draw this? We need 2 points. So how do we get 2 points? Some of you may remember, I think yesterday somebody asked me something about this, Well, it wasn't the same question, another one we were doing or something with straight line graphs previously. So y and x represents the x and y coordinate of a point. So you can use any random x or y value. I mean what I just said. You can use any random x or y value. I would recommend though, use x values to find y because if you use x values, you would have to transpose to find y. But if you use y values, you will have to transpose to find x and you give it some more work. So we need 2 points. Going up to this graph, right? I'm going to use x values from the x-axis. We do not want to use a value that is not on the graph. Like you don't want to use x as a because x 8 is not labeled. You don't want to use 10. You don't want to use 12. Anything you're not seeing here, don't use it. So we're going to use any value of x from the grid. Okay, so I'm going with probably x being 3. So when x is 3, right, which means we are replacing this x here. Let's write it on the side. We're replacing x with 3, so it's going to be 2 multiplied by 3 because 2x means 2 multiplied by x. So if you're using x as 3 to find the y coordinates in the equation, we have to multiply. You can use calculators for this. 3 2s are 6. 6 add 4 is 10. So that means y is 10. So we have a coordinate point here. It means when x is 3, y is 10. So this is 1 point we have thus far. We need another one though. Because you need at least 2 points to plot a graph. Well, a straight line graph. Um, I'm using another random x value. I don't know exactly where this graph would fall, but I could probably use another positive x value. So this time I'm using x as 1, using the same equation. Y is equal to 2, replacing x this time with 1. And we add in 4 to get the y coordinates of that point when x is 1. So 2 by 1 is 2, add 4 is 6. What? Why did I write it there? Write the wrong thing there. Sorry. So 2 add 4 is 6. So it means y is equal to 6 when x is 1. So x is 1, y is 6. So that's how you could find the coordinates of a point. We have point 1 here. I believe it as P1 and P2.2. So since we have 2 points, we can now plot the graph. We have to identify where these points are, definitely. So remember, x is always written before y every time, right? X, y is x, y. We know x is 3 here, y is 10 here. So if we draw lines through them, this point intersects with the cube. Interesting. With the quadratic, I meant. Yeah. So that's one of the points right there for the straight line graph they want us to draw. When x is 1, y is 6, draw lines, let them intersect, and that's where the point will be. Okay, so we have point there. So yes, we draw, I'm going to draw this as long as possible, right? But make sure the line passes through these 2 points for sure. So I think we could start around here. Oh, that was a little bit off. We need them to go exactly through. So trying again. Why getting broken lines and things and stuff. Yeah, so the graph would be something like that. The straight line graph. Okay, I hope you all get screenshots, because when I shift the screen, it's going to shift because I'm using two different annotates right now. So this one going to shift, the others will remain. The next part of the question says using your graphs, determine the solution for the pair of simultaneous equation. So the pair of simultaneous equation is for the quadratic they give us and the straight line we just drew. They said the solutions, right? When they're asking for solutions, um when you're doing simultaneous equations, you all might be familiar, some of you or most of you, you would either find two x's. No, you find an x and y value, right? With simultaneous equations usually. So based on what they want us to do here, we need to find the 2 points of intersection where the graph intersects, the two graphs intersect. That will be the solutions. That's why I said use the graph. So don't go and waste time and find and solve any simultaneous equation. That'll take too much time. This point here is one of the points where the curve, the quadratic, and the straight line intersect. So that's why I said to draw the line as long as possible, because they tend to ask things like this. And then the next point where the curve, the quadratic, and the straight line intersect is here. So the coordinates of this one was what I have on the screen, which is when x is 3 and y is 10. And the other one, well, I didn't have this one, but that is where x is -2, and it's on the x-axis, right? So the y values for points on the x-axis is always 0. Okay, I hope you remember, right? Because this is very important. The x-axis is called y is equal to 0, and that's because every single point that is on the x-axis, the y coordinate is 0. And similarly, the y-axis is also called x equal to 0 because every point on the that is exactly on top of the y-axis, the x coordinate is 0. So these are the solutions they want here. So if it is your word to go and actually work out the simultaneous equations, you will get x being 3, y being 10 for one of the points. Because when you're finding simultaneous equations and you get an x and y value, it is a point of intersection, normally where two graphs, mainly when two straight line graphs intersect. But this one, they give it with a quadratic and a straight line. So it's the points where the straight line and the quadratic intersect. And that's normally 2 points with quadratics, not just 1 point, as with two straight line graphs. So these are the solutions they're looking for. Okay, let me just go down here. So how would we write it in the answer? Spaces are determine the solution of the pair of simultaneous equation using your graph. You could write it like that, or you could put x is equal to negative, all these things on the screen. X is equal to -2 and y is equal to 0. That's 1. The other one is x is equal to 3 and y is equal to 10. Okay. So I hope that's clear. When you have the graph, you don't have to go and work out nothing much. Well, you don't have to use no sort of formula. You just have to learn how to read the graph. So just now, pretty much everything I did was to show you how to read the graph based on what they asked. Okay. All right. If you have questions, you know what to do. Ask the questions. Okay. So I'm moving
But
on. Let
so
me
why
add.
they put that question there? Why they put that equation to work out? The y equal x squared plus
Oh,
x minus 2. Why they put that there? if that don't mean nothing.
It's not that it don't mean anything, they're telling you what the simultaneous equations are. So you know exactly this one is for the quadratic because they give us this before over where it was right here at the beginning when they give the quadratic and said you have the diagram showing the graph for y is equal to x squared plus x minus 2. And then just now, they also give us before the simultaneous equation for the straight line graph. So they're trying to tell us using the quadratic and the straight line, solve or find the solutions, which is the answers for the pair of simultaneous equation. But you would not require to work on the simultaneous equation using like elimination, no substitution method because you have a graph. So that's why they said using the graph. So if you don't follow the instructions and you do something else, you might still get some marks, but you also waste a lot of time doing the actual calculations with following one of the methods of simultaneous equation. So all you had to do was just go up to the two graphs, which was the quadratic and the straight line intersecting each other, and find the 2 points of intersection. And you will get the solutions at the points where the two graphs meet each other. I hope that answered the question. I don't know, but
Yes,
I
it
hope.
answer the question.
Okay,
Thank
great.
you.
You're welcome.